So the first thing that we need to look at is the system catalog. And that is the data about the data. Remember that for every object that exists in a database, the database keeps data about it, and it keeps it in a table. So everything in the relational model is a table, including the metadata. And what we have is, it is a feature of all relational database management systems, but again, there is no standard design or implementation of the metadata. So it's going to change from system to system, how it is implemented, how you access it. So we look at how we do it in Postgres. So we might want to look at the Postgres SQL catalog, and we might, for example, want to look at anything to do with check constraints, columns that are defined, referential integrity constraints that are defined, schemas that are defined, tables that are defined, triggers that are defined, views. All of those will have information that we can access, which is stored in the database. So we need to learn how to do that. Now, what I will advise you to do for this type of queries is to use the graphical query builder that exists, because it makes it slightly easier, and we'll look at that in a minute. So let's say that we wanted to do something like select the information on columns or attributes that we have, including the table name, the column name, the data type, the maximum length of characters for a particular column, whether it is nullable or not, and we want to do that from the information schema columns table, but we only want to do it for the date schema. So for column table, columns.table schema is equal to date. So I am going to now access all of the information for the date schema, because that's what I specify in my workflows, but I am going to look at all of those attributes from this table, which stores information on columns. If I want to build that query, and if I run it, by the way, what I'm going to get is something along this line, which I have. The first thing will be the table name, PSSP, and red part because I've defined that view. Then I will have the column name, followed by whether it is a character, a small integer, whatever data type is defined, because that is what I asked. What is the maximum number length, maximum number of characters, and whether it is nullable or not. So those are the information that I asked in my query, and that is what I got. And if I wanted to do that in the system, the easiest way to do it will be, if I have a query like this, let's see if I can start a new one actually. So what you can do is use this graphical query builder, because if you find the right if you go there to the catalogs and then the information schema there, what I can do is I can select them, for example, the columns, which is the table I want to query. So if I select that, it appears there. And with it there, then I can decide what attributes I want to see in my query. So I could say, okay, I want the table name, the column name, whether it is nullable, the data type, the character maximum length. I think that's what I wanted in that case. Okay? And I could have additional conditions there if I wanted to. So if I want to restrict the value there, I add a filter. And I say the restricted value will be that the table schema, because I only wanted those for the schema demo, is equal to, and then I will have the value there, which is a date or, I can't remember if it's date or date, I think it might be date. So if I now have constructed that query, if I go back to the having done that, on my computer deciding he doesn't want to play ball for some reason. Okay, come back to me. No. Okay, this is because this is there. Fine. So now, having done that, let me just enter that there again. If I now go back to the SQL editor, it will write the SQL for me, and I can run it. And there I have my result. So if you use that query builder to query it's easy to see the tables that you have accessible to you, etc. So you can have all of the different tables that are there. So I will say if you're going to do those from the interactive SQL, do them using this graphical query builder, which allows you to see the tables and the content of it. So we go back to our lecture. So that was the result of the query that you just saw. Let's say that I also want to look at the check constraints. By the same principle, I could access metadata on the check constraints. So in this case, I want to, for example, check constraints.constraint schema, check constraints.the name, the check clause, and the catalog from, in this case, the table that holds information of the check constraints is the check constraints table, and I want to do it again only for the date schema. So I'm going to look at information on the check constraints for the data schema, and what I do if I write that query, which I again quite easily build using the interactive query builder, is I get the schema, which is date, because that's what I selected, the name. Now most of these will be system names because I haven't named my constraints, but in this case, for example, I have named my constraint, so the name that I get is the name that I've given it, which is sctcheck. If no, what I see is the name that the system will automatically allocate. And I can see the type of check clause that I have. Most of them are not null constraints, but I also have one that says the city is not an empty character, the status is greater than 0 and less than 100, and then I go back to some of the null. So I can look at the constraints that I have in that way. Equally, I might want to look at referential integrity constraints. So in that case, I want to look at the referential constraints table, which is going to contain them. And I want to select things like the name, the unique constraint name, the update rule, and the delete rule. So if I do that on the shipment table, which is the only one that has referential integrity constraints assigned to it, then I'm going to have, I've named my constraint. So the first one I've named it as SPS number foreign key. The second one is named as SP number foreign key. This is the name that I've given it. And what I have is for update, here is a cascade action, here is no action. For the delete rule, here is a cascade action, here is no action. So it will show me whatever I have set up when I set up the table. Are you all happy with that? Looking at the metadata? I will take your silence as a yes, because you're old enough to ask questions if you don't understand. So silence will be considered as an affirmative in this. So now we have to move on to functions. So we can create, first of all, let's look at something that you're not going to do because you do not have privileges to do this. You will have to have privileges given by the database administrator in order to do this. But it's good to know that this can be done. And this is, you can create functions in other languages like C, C#, C++, Java, and call them from within SQL. So let's say that I have a table called images, which is going to store, let's say, pictures. And I have, as part of the table, a picture ID, which is the primary key, a description of the picture, which is some text, and then the picture, which is defined as a blob. So I can then, in another language, in C, C#, C++, whatever, create a function that tells me how red that picture is. And I pass the picture of type blob to the function, and the function returns a real. And what I'm doing here is I'm defining where that particular function is stored. So my SQL knows that there is a function library that it has to access where that function is. So I am saying this is a function that has been defined in the language, and I'm declaring it here. Once I have done that, and it's being created in the language C strict. Once I have done that, then I have to code obviously that method that is going to, given a picture, tell me is 50% red or 20% red or whatever. I can then call it from SQL. So I could then have something like select pick ID and description from images, which is the table, where how red, so here I am calling my function that I defined in a different language, and then I pass the picture, is greater than 50. And then order by pick ID. So I am using my function that I defined in another language to make a selection within SQL. So that is possible. But as I said, to do that, you might need admin privileges, which you do not have at the moment on the language. This you can do, which is to write functions that are going to execute a number of SQL statements. And the reason why we might have sometimes to do that is because when we are executing SQL statements, each statement might be hypothetical. Send to the server, wait to execute, come back with the result. And this is going to have an overhead in communications. So what we want to do sometimes is to package a number of statements as a function, then they will execute, and they will then come back from the server where the execution has happened. So that might save from communication time when I'm working with SQL. So I want to sometimes take an arbitrary list of SQL statements and package them together as a function. And what these SQL functions are going to do is they're going to return the result of the last query in the list. So they're going to return something which will be the result of the last query in the list. If we look at the simple non-set, where we're not returning a row, because these functions can return things like a row of values. So if I'm looking at simple returns, then the first row of the last query result is going to be returned. If the last query happens to return no row at all, then the null value will be returned. So I could have something like create function, clean emp, which is the name of my function that I can later call. And this function is going to return void, so it doesn't have any return. It doesn't return anything. And it's going to say as, then I have to delimit the text of my function. And we're going to talk about delimiters in a minute. But one of the ways that we can delimit the text of the function is by using a single inverted comma like here. So I have to say as, and then I delimit the text of my function with this. I have delete from emp, where hourly rate is less than 0. So this is going to delete all of the employees that have an hourly rate of less than 0, because I consider that to be bad data. I declare that this is going to be in the language SQL, so the commands that I've written are SQL commands in the language SQL, and then I can call that language, call that function within a select statement by saying select clean emp. That is going to return the last executed command. In this case, it returns void, because the function doesn't return anything. So if I call it, I won't see a return, but what will happen is the function will execute this. So any employee that has an hourly rate of less than 0 will be deleted from the emp database, from the emp table. So that is a function that returns void. Now, if I want to create function, the syntax of a create function requires the function body to be delimited, as I said, by a single comma. What happens is, if within the body of the function you're going to use single commas to delimit text, then it becomes confusing because you have to put another comma instead of the comma, and it might become slightly awkward. So in that case, you can also use $$ as the notation to delimit the body of the function. So I can write create function 1, return integer as, and then I delimit the body of the function with $$ at the beginning and $$ at the end. So that is the delimiter for my function code. So I say clear function 1, returns integer as $$. This is what the code that my function is going to execute. Select 1 as result. So it's just going to return 1. And it is a language SQL command, so that is fine. Or I could have create function 1 as return integer as $$ individual comma instead of $, select one as result. So I can either use the dollar delimiters or the single comma delimiter. But if I have single comma used within the body of the function, it's better to use the $, because then there won't be confusion. So if I execute that, the function is going to return just 1. Now, when we have arguments, we can have, these functions can have input parameters and output parameters, like any other function. And the arguments to the SQL function are going to be referenced in the function body using the syntax $n. So $1 will refer to the first parameter, $2 will refer to the second parameter, $3 will refer to the third parameter, and so on. If an argument is of a composite type, so it has more than one field, then we can use the dot notation. So for example, $1 name, $1 S number, $1 whatever, to access the attributes of the argument. So for example, let's say that I have a function called addThem, which is going to take one parameter, which is an integer, and another parameter, which is an integer. So there I have to define the parameters that I have and the type. So I just define that I have two integer parameters, and this function returns an integer. It's going to take two numbers, add them, return that to the calling environment. Then I delimit the body of the function with $, at the beginning and at the end. And I have select $1, that refers to the first parameter, so that is going to be taking the value of whatever is the first parameter that I put when I call the function, plus $2, that refers to the second parameter, so it's going to take the value of whatever I pass to the function when I call it. And then I have to say that this is a language SQL function. So if I then call this select addThem 1 and 2 as answer, what I get is that answer is going to have 3. If I have select addThem 3 and 7 as answer, then answer will come up with 10. So it's just going to add the integers together. They are passed as parameters, so it will add to wherever I pass in the first parameter with the second parameter. Are we happy with that? It will return it, and that is what we're going to see as answer, because it returns the last SQL statement that was executed. So if I wanted to write something like a function that returns a balance from an account, I can have a function called tf1, and by the way, if you write create or replace function, if the function exists, it will replace the content with the new content. If you just write create function, if it exists, it will complain that that function already exists, and you have to drop it before you can actually rewrite it. So it's good practice to write create or replace function, because then whatever is there will automatically be replaced by the new definition. So in this case, I have an integer and a numeric variable, and it returns a numeric variable as the $, identifies that this is the beginning of my function code. And what I have there is, first of all, an update bank statement. So it's update bank, which is going to be the table that I am updated, send balance, which is one of the columns I want to update, equal to balance minus whatever I pass as the second parameter when I call it, where the account number is equal to whatever I pass as the first parameter. And then I have a select statement, so what I can do with these functions is pack a number of select statements or update statements or SQL statements together. So I can have select balance from bank, where the account number is equal to 1. So that is going to now return to me the balance of the account that I've just upgraded. And so if I call that with 17 and 100, what happens is that as it executes, it will say update bank set balance equal to balance minus 100, because that's my second parameter. So if my balance originally was 1,000, now I'll have 900, where the account is equal to 17. So this will refer to a particular account number. And then it will select balance from bank. So that is going to select my new balance of 900, where the account number is equal to 17. So it will then return the balance to the calling environment. And that is what I will see. Because what I will see is the execution of the last selected statement. All of them will happen, but the return will be the execution of the last selected statement. Are we all happy with that? Static. Super happy. Good. So, what about if I, instead of returning just a number, I want to return a composite type, like a row type, so I have more than one value in my return. So what about if I have a function which is called create function, or it could be create or replace function, double hourly rate from the table emp. So this time what I am passing is, at this point I'm not returning a composite type, but I am passing to the function a composite type, a row. So I'm not passing a single number, I'm passing a row of values from a table, which is the table emp. So return numeric as, and then there begins the body of my function. So I have select, and this is where I can use the dot notation to refer to the different parts of my composite type that I have. So I've passed an emp table, and inside of there I want to say $1, which is my first parameter, so it's my emp table, dot hourly rate. So the hourly rate of that I pass as a parameter, I multiply it by 2, and then I call it as hourly rate. And what happens is, if I now call that, which I can call within the body of another select function, I could have select name, hourly rate, and then double hourly rate emp. So that is calling my function in there, within my select statement. I'm calling my function double hourly rate, and I am passing the whole of the emp table to it, emp.star, as dream from emp. When I execute that, what I'm going to get is all of the data that is in the emp table, and the hourly rate that they had originally, because that's what I selected, and the hourly rate that my function calculates, which is the hourly rate multiplied by 2, so double. So that is what my function is going to do. And if I show you there, so there is my function there. Now if I put create or replace function, if my function exists, it will automatically replace whatever I've written before with the new code that I'm executing, provided it's valid. So I could run that, and it says query return successful, which means there was no problem with the definition of that function. So if I now say select name and so on, what I am going to get there is the name, the hourly rate, and the result of multiplying it by 2, which is what my function is doing. And once you have defined functions on your data, you can actually see them. So for example, here I have 3 functions. One of them is the one that I explained to you earlier, the add function, which will add 2 integers. That is the one that doubles the hourly rate. There's another one for updating the hourly rate. So they are going to appear there, my functions, as part of the objects that are in the database. And there will be stored metadata about those functions once I have compiled them and they are in the system. So I can then call them from within SQL, because they become an object in my database that I can use in other select statements. Are we all happy with that? When you come to do SQL, you don't have to use functions necessarily. You could write your SQL without using functions. There might be some brownie points if you use them. So you might want to, at some point, try to use them, but you don't have to. You can get away with not using functions.
If we write a function and function which has the same name and with a different number of parameters, how it works as in C++ or in Java?
If it has this, I think if the function is already defined, it won't allow you to add, to create another function with the same name and a different type of parameters. I mean, you can delve into it quite a lot, and then you can, there is ways in which you can define the parameters to take different type of variable type of parameters, but I think that is getting into quite complex stuff. But there are ways in which you might be able to leave the type of the parameter open, so you can pass different type of parameters. But I haven't gone into that much detail myself. But I think once you have defined a function, if you try to define a function by the same name, it will probably complain. So what about if what we want is a function that actually returns a composite type? Because so far we have seen a function that takes as a parameter a composite type. We could also have a function that returns a composite type. So we could have a function called create or replace function, preferably new m, which creates a new employee record. And we could have that returns m, so returns a composite type. As, and then I define the body of my function with the dollar notation. By the way, within the dollar notation, you could have a word. So you could have dollar body dollar at the beginning, at the end. That will also be feasible. Whatever you put within the dollar signs is okay. So I could have as select, and then I am going to enter data into my composite type. So 900 as MPID. I might have to, for the text, if I'm using this, I might have to cast none as text by using the word text before to say this is I am entering something of type text. So that's just a cast of the value none into a text as name. Text, again, is a cast. Analyst as title, 50 as hourly rate, 691 as manager ID. So all I'm doing is I'm entering that, and then I'm returning that into a calling environment, because what I'm returning here is emp. So I filled the data in this record, and I'm returning it to the calling environment. So the order of the attributes in the select statement must be the same if I do this as the associate table, because I'm trying to enter the data. And we might have to, as I said, typecast expressions to match the definition of the composite type to make sure this works, like I did with the text in there. Now, if I want to call that function, then I could have select new m, bracket, bracket, and that is a call of my function. So that is going to then return to me all of the data in one field. So what it will return is a text string that contains all of the data that I entered, if I call it like that. Or I could say select star from new m. If I call it like that, it will delimit my fields and tell me that MPID is 900, name is none, title is analyst, and hourly rate is 50, and manager ID is 691. So it's just how it displays my information, and depending on how I call the function. All of the SQL functions, you can use them in the front clause of a query. So you can use an SQL function, as I have there, in the front clause of a query. So I have, say, from new m, because it returns a table. Or I could also have something like insert into m, select star from new m. So that is actually inserting into the employee what I get as the select, as the return of that function. So far, we have looked at how we write functions that combine more than one SQL statement. But what we haven't got into, which we're going to get into now, slightly, is the procedural part of SQL. Now, when we've talked about SQL, we've said SQL is a declarative language because we say what we want, but not how we want to obtain it. And other languages that we're used to, like C, C++, Java, COBOL, Pascal, are procedural languages where we have all these kind of like procedural statements, things like while loops, for loops, etc. Now, SQL is declarative or it's non-procedural. So we just specify what we want. But sometimes we want to have access within SQL to procedural constraints, procedural aspects of the language so that we can write more complex SQL statements. So as the years went by, the vendors started to add, and in fact, also I think they were added to the SQL standards, other extensions to the language. Triggers, stored procedures, etc. Triggers and stored procedures, they are non-declarative database objects, which are stored in the catalog. So as the functions that we see, so if you create a trigger, if you create a procedural, a stored procedure, they become part of the system catalog, but they are non-procedural. And there are statistical differences of those objects with the objects that we are used to, and they don't follow the standard precisely. What we have with this type of language is that we can have a piece of code which has a declarative SQL statements like the create, update, select, etc., but they can be complemented by things like if-else statements, while loops, for loops, etc. So we add all of that to our ability to write SQL. The code, as I said, is stored in the database, in the system catalog. They become objects in the system catalog. And then we can call those procedures through other SQL statements or from other stored procedures. So we can call them as we did with the functions. And they can also be called from different host languages. So we could call them if we're writing a program in Java or if we're writing a program in C. We could call these stored procedures. We could use the triggers and so on. Now the syntax for this is going to have three elements. A parameter list as we did before. So we have input parameters, possibly output parameters. Variable declarations, because we can have variables now in the code, which we use within the code to allocate to whatever we want. And then we have a procedure body. Now, in PostgreSQL, what we have is functions. So the functions take the place of the stored procedures. So we write functions in a specific language, which is called PL/PGSQL. And that is what 39 chapter of the online help is about. So if you want to learn to write this kind of code, you can look at that, and it will give you ideas for how you write a for statement, a while statement, etc. So we can have something like that. By the way, the first time that you do that, you have to create the language within the database. Once you have used the create language statement once, you can write other functions, and it won't ask you to do this again. But if you've never written a function on PL/PGSQL, the first thing that you do is you use this command called create language PL/PGSQL. Once you have done that, you can write then more functions, and the language will be created within your environment. So you only need to do that once, and then I can have a function called update hourly rate. Now the difference is that now I am going to have a declare part where I can declare variables. I am going to then have a procedural part where I have a case statement, and I am also going to have in that SQL statements that I can execute. So with this type of functions, I can combine more powerful approaches. So this procedure is going to be called update hourly rate. It takes two parameters, which are input parameters. I've defined it as in, so they're input parameters, and they're both integer types. And that procedure is going to return void. They can return, as before, composite types, they can return numbers, they can return reals, etc. And then I have to delimit the body of the procedure. Now I have a declarative part where I declare the variables that I'm going to use. So I have one variable called rating, which is an integer, and which I initially assign a value of whatever is passed in my second parameter. Because $2 refers to my second parameter. Then I have another variable in that procedure called the ID, which I define to be of type integer, and which I initially assign to the value of my first parameter. So whatever I passed, the second parameter is going to become the rating, the first parameter is going to be the ID. Then within that, I have a begin and an end, which delimits the body of my function, and I have a case statement. So the case statement in this language, I have case rating. When the rating is 1, then I execute a bit of code. When the rating is 2, then I execute a different bit of code. Else, I execute another bit of code. And what I have is that when the rating is 1, I am going to update the demo.emp record, and the hourly rate is going to be multiplied by 10%, so I'm going to give whoever a 10% right, where the emp ID is what I put in my variable, which I copied at the beginning in that initialization. When the update is 2, then when the rating is 2, then I am going to give them a raise of 5% to whoever I copied into this DID, which is the parameter that I passed. And in every other case, I am going to give them a raise of 3%. So if I execute this with a select update hourly rate, and I pass 578 and 2, then I am going to take my employee 578, and I am going to give them a raise determined by case 2, which is going to be a 5% raise. If I had done the same with 1, I would have given them a 20% raise. If I passed anything else, it would have been a 3% raise. So that is allowing me to combine code, which could be while loops, etc., with selected statements as part of a function. And there is also things like error handling within it, and so on. So it's quite a complex language. You don't have to get into it, but if you want to, you can. It's up to you. You could do the same. You don't have to, for the exercise I'm going to set, use this kind of thing, but it's good that you know it's there, and if you want to use it, there is a facility there for you, so you could try. Are we all happy with that? Now, the next thing that you need to know about, and which is quite helpful sometimes, and sometimes you are well advised to use within your assignments depending on what you're asked to do, is the issue of triggers. Now, triggers are similar to store procedures because, again, they have declarative, executable, and conditional handling sections, and they are not quite defined in the standard SQL. What makes triggers differently is that with a function, I have to call it for it to be executed. A trigger is executed automatically whenever the triggering event occurs. So they are very good for certain things like maintaining complex constraints, maintaining tables which keep record of what happens in the database, audit tables, enforcing particular difficult constraints to enforce, doing automatic updates. All of these things we can use a trigger for. You cannot call a trigger specifically. It will execute by itself when the triggering event occurs. And an SQL trigger is something that is axiomatically executed when there is the action, which is either going to be always an insert, an update, or a delete action, occurs on a specific table or on a column of a table. So what we have is, as I said, we can use them for validating input data, where the validation is complex. We can use it for maintaining complex integrity constraints, where we have to check more than one table. Before we insert, we could use a trigger to make the checks. We can use them for supporting alerts. So for example, if you have a reorder table and it's getting to a particular reorder level, then we could have a trigger that sends an email to say you need to reorder this particular item. So we could have alerts like that. You can use them to maintain outdated information. So every time a table is changed, you record who changed it, what was changed, etc. And you can also use it for supporting replication in distributed environments where we have to replicate table. Or things like we mentioned before, if you wanted to have views that were materialized, you could use something like triggers for that. So the syntax of a trigger is like this. We have create trigger name. So we give the trigger a name, and then we have to decide whether it's a before trigger or an after trigger. So what is going to happen either happens before the event or after the event. Before the insert or after the insert, before the delete or after the delete. On a particular table, whatever table this trigger is going to act. And this could be an action that happens for every row, or only one for every statement that you execute. So we can do it for every row, or for every statement. And we can have additional conditions when a particular condition occurs. Then what we do is we execute the procedure function name. Now this procedure has to be declared as a trigger function. So it's a specific kind of function called a trigger function. So we have to create the trigger function, and then we call it within the trigger, in the case of PostgreSQL. So let's say that I have my summary table. And what I want to do with my summary table, remember that my summary table is that one that keeps a summary of all of the parts that were shipped for a particular part. So for part 1 is 800 and so on. So what I might want to do is every time I insert a new shipment, I update automatically my table, my summary table. I could do this with a trigger, because every time I insert, automatically the trigger will set the action that I want to happen. So this is going to happen without me having to do anything every time I insert. So then I can have something, let's say that I have a summary table, which is got a part number, which is a character, not null primary key, and also a total quantity, which is an integer. So I've created my summary table. Now, as I insert shipments into my database, I want to maintain that current. So every time I insert into summary, every time I insert into a new part, I want to insert into summary, this might be my initial statement, the part number and the sum of the quantity from shipment group by P. So this might be my original table. But then every time I insert a new shipment, I want to update my summary table. So for that, I could specify a trigger. So the first thing I want to do if I want to have a trigger is to have a function which is of a type trigger function. So I can call that function within my trigger. So then I have a create or replace function, date.update summary, because it's going to act on the date schema. And this function is defined as being a trigger function because what I return is a trigger. So that defines it as a trigger function, which is what I need in order to call it from a trigger. So it returns a trigger as, and this time I'm using $body to identify the beginning of my function. I say I could put anything between the dollars, so this time I've put the word body. Then I match it at the end, so that's fine. Then I have a begin and an end statement. And within that, I have my trigger. So what I want to say is, okay, if, what I have to be careful here is, if I have a part, because I have assumed that I've already got a summary table which has some parts in it. If I am inserting a new part that is not in the summary table yet, I might have to treat it differently to if I try to insert a part which is already in the summary table. If I'm inserting a new part, then I need to insert it into the summary table. If I am adding a new shipment to the part that exists there, then I need to update the total quantity, adding the new quantity. Are you with me? Or not? So I have a summary table, and I have compiled the summary table at some point. So I can either insert a new part, in which case then I have to insert it into the summary table because it's not there yet, with my whatever is my shipment. Or I might already have a row for that because that part has already been shipped, in which case I might add to the count that is already there. So those are my two scenarios that I have to cover. So I have to write begin if, now within a trigger, I can refer to the object associated with the calling action. If it's an insert, there is a new object that I am going to insert, and I have access to that object within the trigger function. If it's an update, I have a new object and a null object. If it's a delete, I have a null object. Okay, so in this case, I'm saying if new.pNumber is not in select part number from summary, so I'm dealing with a new part that is not in my summary table, then I want to insert that part in my summary table so that I can start to keep a summary for that part. Insert into summary values new.p number and new.quantity. So that is a straightforward insert. I have a part, it has never been in my summary table, and I insert it. Else, i.e., the part is already in my summary table, then what I'm into is an update. Update summary, then set total quantity equal to whatever is the first non-null argument. This is what coalesce does. Coalesce returns whatever is the first non-null argument. So it's going to either be the total quantity or 0. So if the total quantity becomes null, it will return 0. Plus the new quantity that I am inserting, where the part number is equal to the new.part number. So I'm matching the part that I am trying to insert. And then I have to have an endif. Now, if I've created this function, which is actually the action that I want to perform on my trigger, what I now have to define is my trigger. And my trigger is going to have create trigger. I'm going to call it total shipment. After insert. So that means that every time I try to insert on the SP table, after I insert, this code is going to be executed automatically by the system. So every time I insert a new shipment, the code above gets executed. If I said before insert, the code will be executed before I insert in the shipment table. And it's for each row. So this is going to execute for each row that I try to insert. It could be only once per statement, but in this case it makes sense for each row. And what has happened is, automatically, every time I insert on the shipment table, this is going to be called. So this function is going to be called and execute. So my summary table is always going to be kept up to date by my trigger. So if I now, I'll show you how. So if I now say something like insert into shipment values S2, P6, and 1000, so as soon as I call that on SQL, what happens is the trigger is implicitly executed by the system. I don't have to do anything about it, because every time I insert, that trigger code is executed. It's executed after I insert. So this insert happens, and then it automatically goes to update my summary table. And if that operation fails, the whole insert fails. It will return with an error. So the insert will only happen if the trigger manages to execute as well. And what that trigger is going to do is, if S2 is already in my table, then it will execute this. Update summary, set total quantity equal to total quantity plus 1000, which is my new quantity. If P2 was not in my table, then it will insert it in my summary table with a quantity of 1000, which will be my initial summary. Are we happy with this? Less happy. You have to try triggers before you understand them. What you're going to get is the fact that these are automatically executed by the system as you specify, either before the triggering action or after the triggering action. Okay, so you got to think about, when you think about triggers, things that you're not going to call them, they will automatically happen. They will execute automatically before or after the triggering action. So, the kind of events that we can have are insertion, deletion of rows, or update of columns or rows. So I can have a trigger when I insert data, I can have a trigger when I delete data, or I can have a trigger when I update data that executes. The action can either happen for each row that I manipulate, or just one per SQL statement, whatever makes sense. And you can refer to a null value or a new value. So if you have an insert, the associated value that exists is a new value, because you have a new value that you're trying to insert. There's no old value. If you have a delete, what you have is a null value. There are no new values. If you have an update, you have both an old value and a new value that you can refer to. And you can refer to them from within the triggering function. What you cannot have in a Trigger is you cannot have commit or rollback statements. So you cannot have transaction statements. You cannot have connections to the database within the trigger. So you cannot try to connect to the database within the specific trigger. And you cannot have a schema definition of manipulation statements. So those are not to be part of a trigger. Another example is, let's say that I want to keep an audit table. So every time somebody makes a change to my supplier table, I want to keep that. And I want to implement a trigger to record all of the updates or deletes or inserts on the particular table. So first of all, I need to create a table that is going to maintain the changes. So let's say that I have a table called subchange, which is going to keep those. And I have the first field of that is the user. So I'm going to record the username associated with the user that has made the change at the time, which I can get from the system. I can get the time at which the update or delete or insert happens from the system. I then want to, in this case, I want to look at changes to the S number. So I'm going to track what the S number does. So I'm going to have the S number associated with the change, the type of change that happens, whether it is, and I am going to constrain that to be either I for insert, U for update, or D for delete. So that is going to be the type of change that happened at that point. And then I am going to have possibly a new character if it is an update, a new S number that happens. So, and I have to define a primary key on that table, which might contain all of those fields. Now I want to create a trigger, which is going to maintain my table of changes. So it's going to insert into that particular table. So I have to therefore create a function, which is a trigger function. And I'm going to call it maintain changes, and it's going to return a trigger. Because it's a trigger function, it has to return a trigger, otherwise it's not a trigger function. As $begin. And then what this function is going to do is insert into this table over there the user, which is the user-defined value, which I can get from the system, the timestamp, which is again something I get from the system, then the old value of the S number, the fact that what I'm doing, so this is only for updates, the fact that I'm doing an update, and then the new number. And this is going to return new value, the new value that I've just updated, and then end. And that is defined as being of language PL, PG, SQL. Now, once I have defined the trigger function, I have to define the trigger that is going to call that function. So I say create trigger update soup after update on S. So every time I execute an update on the S table, this trigger is called. So every time I have an update on the supplier table, it will actually execute the bit of code in my function. For each row that is updated, so it's going to be executed for every time I do an update, and what I execute is that particular procedure. So if now I say update S, set S number equal to X9, where S number is equal to S2, that is automatically tracked to my table, and what I'm going to have is, this is my username in my own local system, so this is my username called Postgres, the time which is taken from the system, the type of update, which is an update, and the newest number. So this was a change to X9. No, from S2 to X9, sorry. So that is, because I can't see it because they are together, but S2 is the old number, X9 is the new number that I've altered to. So the ordering of trigger events is going to be like this. We have a trigger event is executed, so what happens is any before statement triggers are executed, then for each row that is affected by the trigger, we then execute any before row level triggers, then we execute the statement, then we execute then we do any referential integrity constraints, then we execute any after row level triggers, and then finally we will execute any after statement triggers. So that is the way that the order of events will happen.